So before we are starting with coding, let's just quick talk about what a tree is and what we are talking about. So we're talking about binary trees, which means we have a root node, and from that node we have different other nodes, but only two we have. So if this one maybe has a value of, what was that? So I could write in here, has that has a value of 5, and then we have another one, which is this, has a value of maybe 2, and the next node has a value of 8. Then they are ordered like this. So we have this root node from where we started from, then the node with 2, which is smaller, so it goes to the left side. And we get the next node, which is 8, it's going to the right side. And now if we get another node, which is, let's say it's 4. It checks in here, is 4 smaller than 5? Yes. Then it goes left. There's 2, is 2, is 4 smaller than 2? No. Is 4 greater than 2? Yes, so it's going to the right in here. So now we have the 4 in here, and we could draw some lines. So this goes here, this goes here, this goes here. If we now get another node, which is like 1, it's smaller than this, smaller than 2, so it's going over here and has a value 1, and this connection. So that is a binary tree, and now there are different possibilities how to traverse or how to read this tree. We can start here at the root and go to the left side, print this root, go to this one to the left side, then we go to the right. Or we start all down here, go to the 1, then to the root, then to the right, then to this root, then we're going all up down here to the left. We have, so the last one would be the 8. Or we're going different, we're starting totally right. That's tree traversal. So, and enough of that. Now I just want to show you that how to do that in Java, where we build we create a small tree implementation, the very small basic stuff, and then I will show you 4 different types of tree traversal for that, which you can use in any other programming language too. It's all the same. So today I want to talk about traversing trees in Java. For this at first we need a tree, or at first we need a project. I created one here, but now we need a tree first. Or first we need a main class with public static void main method. And now what we use a lot in talking about data structures are nodes. Nodes could have generic types, so we could insert any stuff here and then compare that. But for simplicity, I will just use an integer as data, and every node will also have a left side and a right side, and maybe we'll give the constructor which takes int data, and this data equals data. So next step would be creating the tree. The tree only needs one property, which is a node cat, and let's say it's private, so we can't access this from outside. So now we just need a few methods, public methods. like void add. Here we want to add our value or data. And now we need some little helper method which will return a node. And we say add node, takes the node as a parameter and our data. So, and in here we check if this node is null. Like this head here, it's null. We could write null, but it's done and we can just say that. So it's null. You can say, okay, then we return a new node with that specific data. If data is bigger, if we have a node and the data is bigger than the node data, then we can say node dot, because we want to sort and the right side is always a higher number, not the right. Yes. Add node, and now we don't know is it the last node, so we need to go recursively in it, say data in here, or we can maybe our data is smaller, so then we say node dot left, add node dot left data, and if not, we just return the node. So it's smaller in here, and we say head is head node. Head, we start with the head, and this is the data. Now we could go in our main method and create a tree. Tree. And now we can say tree dot add 2, a bit more, 2, 7, 3, 5, another 2 again, 8, and at the end we get 1. So now we can try if it is running or we got some errors. Okay, no errors yet, but we don't see anything else, so we need a print method. So we can just say public void print, and here we will print our value, but right now we need to a little helper method, and I will just say public helper, and we say in order, or just say in order, and this is a void, and takes the node as a parameter. And in here I just have to check if node un equals null or not null. Then I can say, okay, we want to be in order, so the smallest number, first the smallest numbers are on the left side, then there is a root, and then the bigger numbers on the right side. So we have to say in order, and we need node.left. Then we can system out our data, and then we go to the right side and say node dot right, and now we go in here and say in order we start with head. So now we can go in here, no, not in here, here, and say tree.print, and I hope that will work. Let's go. And we see 1, 2, 2, 3, 5, 7, 8. But what is not good right now is that we have the two times, so we need to reduce. So that's because in here I just have else. If I say else if, and then say smaller, and that should be doing it. Perfect. So now, as we have Inorder, we can maybe say a little bit, let's create an enum in here, which we can name order, and let's say order, and here we can say in order should be small, in order what was others were preorder, and postorder. And now we can maybe give a parameter in here, which is order, and if order is switch order, and now we can say case in order. Oh, what's that? Nice syntax. And then we can say break. What's that? Okay, nice. I don't know the syntax. Seems to be new. So let's see if it's automatically break. Yeah. Now we need some other methods here. Let's create a preorder, which is root at first, so we just data at first, and then we say postorder, where we have right, root, and left. Or what is postorder? No, I think it's actually left, right, and then it's postorder. So we can go in here, say preorder, add, and last case postorder, add. And if that's working, we can go in here, okay, so order, in order. Let's try this again. Works. Let's say, let's just move that. Preorder 2, 1, 3. That's working too. Our head is the 2, and the smallest only to the left is this 1, and now it's postorder. Yes, this works too. This is the 1 on the left, and this is 3 on the left. So it's actually all. We just need to create some. We just have some tree, and to have the different orders, we just need to specify. Okay, it's now in order here. Maybe it could be better. That doesn't really matter. So now it should be right. Again, yeah. 1, C, left, right, left, right, head. I guess that's working. So that's all about trees. We create a tree, giving a head, adding a method to add nodes, and we all do that recursive. We add nodes recursive, we print the orders recursive, and now in this we just need to arrange if we want to print the head, the left side or the right side first for our specific orders. Should also be possible to do reverse, try that and add in here reverse order, and let's add it here, reversed, oh, I killed one, reversed, say it, one word. If you go in here, not here, not here, you can say reversed order, head, and with some luck it should be reversed. Oh, not. Also, I didn't even sorted it. So what do we need first? We need first the right side, then we need the head, and then still this again. So let's see if it's not working. 8, 7, 5, 3, 2, 1. So that's working. And I think it's most easy to see if we have in order or reversed order. So if we do that and say in order, we see it's perfectly matching. So that works, and it's kind of pretty easy. So only the hardest is harder to build the tree than traversing the tree. So I hope you saw how easy it is, and so you will have no problems in any exams about it.